let us now next see how to permute objects which are not all distinct. Suppose we want to find out the number of permutations of the letters of the word root. Now here all the letters are not distinct, so we don't quite know at this stage what to do. So let us instead consider these two O's to be different. Let's assume that they are different and find the number of permutations, as if we are permuting distinct objects. They are actually not distinct, but let's just do first what we know, and then we will see what we are getting, and from there we will try to figure out what to do. To distinguish these two O's, we have named them O1 and O2. So now, like this, we have forcefully got four different objects. So how many ways are there in which we can permute them? 4 factorial, obviously, which is 24. So the total number of arrangements or permutations is 24. But that is not the answer. Had there really been 4 distinct objects, the number would have been 24. But these two O's are not really distinct. They are the same, they are identical. So then what shall we do from here? Among these 24 arrangements, you have these two arrangements also, where here you have O1 and O2, and in another one you have O2 and O1, right? Because you are considering these two O's to be different, so if you normally arrange the 4 letters, in the 24 arrangements, these two will appear. However, actually because these two O's are identical, so you are not really getting two different arrangements. Originally, you just simply get root. Similarly, in another type of arrangement, you have TORO, which just simply is TORO, but because of the way you are counting things, you get 2. So every time you have some arrangement, it is getting doubled because of what you have done here, that you have distinguished these two O's, which actually are just identical. So that means you should really get how many? 12 arrangements, not 24, which means that you are having to divide 24 by 2. But what is this 2? That we have to understand now. So the actual number of arrangements is 12, which is 24 divided by 2. But here notice that I have written 2 factorial. Is it really necessary to write 2 as 2 factorial? Actually, it is 2 factorial, which however is 2, that's a different matter, but originally it is 2 factorial. Why? Let me take another example, that it will become clear. Suppose I consider an imaginary word consisting of these 4 letters R and 3 O's. There is no such word, but say we are considering this. And now I want to know in how many ways I can arrange these letters to get distinct arrangements. Here we have 3 O's. So if I proceed just like the word root and distinguish these 3 O's as O1, O2 and O3, then I get 24 permutations, because now we have 4 distinct objects, but actually that is not 24. So in this case, what should we do? Now in this case also, of course, all you have to see is how many times things are getting repeated, that's all. Now among these 24 permutations, you will have these 6 also, where the word starts with R and then you have 3 O's. Really that is just one word, because the O's are identical, but because you have forcefully assumed them to be different, so they will now arrange themselves in 6 ways. Why 6? Because that is 3 factorial, the number of ways you can arrange 3 distinct objects, taking all of them at a time. So that is why this time you have to divide 24 by 3 factorial or 6. And you can imagine that there will be other words also, where say it starts with O, then R comes, and then two other O's come. Like that, there is only one word. I mean, if we are calling this type of things words, O, R, O, O. But because of this distinction, there also you will get 6. So that is why you are having to divide by 6. So the actual number of arrangements here is 24 divided by 3 factorial, or 24 divided by 6, which is 4. And you can see that these are actually the arrangements. So only 4 in number. Whereas if you consider them to be different, then you are getting 24, which is wrong anyway. Now you can record this observation in the form of this theorem. The number of permutations of n objects where p objects are identical and the rest are all different is n factorial divided by p factorial. And in fact, you have a much more general theorem. The number of permutations of n objects where p1 objects of one kind are identical, p2 objects of another kind are identical, and like that the pattern goes. Pk objects of another kind are identical. These kinds are all different, okay? And the rest, whatever there are all different is this. N factorial divided by, this time because of these different kinds available, p1 factorial times p2 factorial times p3 factorial, like that it goes, and finally you have pk factorial. So now that you know how to calculate the number of permutations of objects which are not all distinct, let's consider this example. Here we have to find the number of permutations of the letters of the word Allahabad. So you can see that many letters are repeated. So you have to first of all see how many letters there are in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not taking into account repetitions. So you write 9 factorial. But that's of course not the answer because these are not all distinct. Is A appearing more than once? Yes. How many times? 1, 2, 3, 4. So you divide by 4 factorial. Is anything else also repeated? Yes. L is appearing 2 times. So you also write 2 factorial here. Anything else? Besides these letters, you have H. No, that is appearing only once. B, that's also only once, and D only once. So this is your answer, and that comes from this, of course. So let's see another example. This time the word is independence. Here we have to find the number of arrangements. So we start by counting the total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 factorial. And then we see the repetitions. What about I? I appears only once. N, 1, 2, 3. So we have written 3 factorial. Okay. D, yeah, D has appeared more than once. 1, 2, that's it. So 2 factorial. Then E, 1, 2, 3, 4. So 4 factorial. And you can check that no other letter has been repeated. I mean, it appears more than once, the remaining ones, each one of them. So that is why this is the number. But there are some other parts in this example also. So next, let's see them. Part 1. In how many of these arrangements do the words start with the letter P? So if you are restricting the word to start with P, that means the first place is occupied only by P. So you cannot change that. It is always P. So that leaves us with remaining how many letters? 11 letters. They can only be arranged among themselves. So you write 11 factorial this time in the numerator. However, you still have to take care of those repetitions. So the denominator stays the same. part 2, in how many of these arrangements do the vowels always occur together? To keep the vowels together, we actually write them together like this. Besides I, you have these 4 E's. These are the only vowels. And then we have written the consonants also, the 3 N's. To make things more clear, we have written the N's together, the 2 D's together, and besides them you have P and C. To see you have really written all the letters, you count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So now, these letters have to stay together. That means you cannot change this box. Change this box in the sense you cannot take anything out of this box. Within the box there can be change among these letters, but the box stays. The box itself moves as you permute these objects now. These are 7 objects and this is another object. So the number of things you are permuting now is 8. Okay, and there also they are not all distinct because we still have these repetitions. So you start by writing 8 factorial. To take care of these repetitions, you divide by 3 factorial and 2 factorial. 3 factorial because of these 3 n's and 2 factorial because of that 2 d's. However, this single unit also has something happening inside of it because there are 5 objects here, right? So they will arrange themselves in 5 factorial ways, but there also 4 things are appearing which are identical. So you are dividing by 4 factorial because these things are happening together. That's why we have to multiply. This is the total number of arrangements in which the vowels will appear together. Part 3, in how many of these arrangements do the vowels not occur together? And that number is this number minus this number. This is the number of arrangements in which the vowels occur together. And this is the total number of arrangements without any restriction. So that's why this minus this. And finally part 4, in how many of these arrangements do the words begin with I and end with P? So now we have restricted 2 letters I and P. We cannot touch them. But besides them there are 10 letters which you can arrange. So you write 10 factorial here. However, I and P themselves are not among the repeated letters. The repeated letters are still there. These 4 E's, these 3 N's and these 2 T's. So to adjust for repetition, you still have to divide by this number. So the total number looks like this.